Example 4. Determine the type of symmetry each equation has by reviewing the appropriate graph from example 2. Then confirm your observation by testing each equation algebraically for symmetry, x-axis, y-axis, and origin. In example 4a, the equation is y equals x squared minus 3x minus 4. If you flip back to example 2a, we found the intercepts of the graph of this equation algebraically, and we also graphed the equation by hand. Okay, so we're going to start by flipping back to example 2a, which is on page 3, okay, and we are going to look at this graph that we drew, okay. We are going to visually observe what type or types of symmetry this graph has. Let's start with x-axis symmetry. Okay, so to visualize this, you want to imagine that this graph or grid is a sheet of paper that you are going to fold along the x-axis. So you would be folding the sheet of paper along this red dotted line. Okay, and you're going to ask yourself, does the top half of the graph lie on top of the bottom half of the graph if I were to fold the sheet of paper in that manner? And the answer is no. Okay, so this graph does not have x-axis symmetry. Okay, if you have trouble visualizing it that way, then here is another thing you can do. Okay, pick a point on the graph. Okay, it can be any point you want, but I would avoid picking something that's on either the x-axis or the y-axis. Okay, so I'll pick this point right here. This point right here is 3, -4. Okay, what we have learned, if a graph has x-axis symmetry, that means the point that has the same x-coordinate but the y-coordinate has changed sign should also be on the graph. Okay, so that means in this case, if we're looking at the point 3, -4, then the point 3, 4 should also be on the graph. Okay, well, here's the point 3, 4. It's not on the graph. Okay, so there is no x-axis symmetry here. Okay, all right, so now let's think about y-axis symmetry. Okay, so here we go. This time you want to imagine your sheet of paper is being folded along the y-axis. Okay, does the left half of the graph lie on top of the right half? And the answer is going to be no. So here there is no y-axis symmetry as well. Okay, but again, that may be difficult for you to visualize. Okay, and so we're going to do the whole thing where we pick a point. Okay, so in this case, what I will do, I'm going to pick the same point that I looked at last time. Okay, so we'll take a look at 3, -4 again. Okay, and that is on the graph. So if this graph were to have y-axis symmetry, that means that the point consisting of the x-coordinate with a different sign, so change the sign of the x-coordinate but keep the y-coordinate the same. Okay, that means we need to look at -3, -4. Is it on the graph as well? Okay, and if you find that point, -3, -4, here it is not on the parabola. Okay, so there is no y symmetry here. Okay, origin symmetry, we need to check for it. Okay, it is always the most difficult to visualize. Remember, it involves flipping over both the x-axis and the y-axis. So I would just look at a point here. Again, we'll take our old friend 3, -4, that's on our graph. We know that for a graph to have origin symmetry, you need to change the sign of both coordinates. So we would be interested in the point -3, +4. Okay, is that point on the graph? Okay, and if we look at -3, +4, that is right here. Okay, that point is not on the parabola, so there is no origin symmetry here as well. Okay, so what that means is this particular graph that we've been looking at, this parabola, it has none of the 3 types of symmetry. Okay, so when we go back to do our tests, okay, we should get a no for all 3 types of symmetry. Okay, so I'm going to go ahead and write what we've observed. There's no symmetry for this particular parabola. Okay, we've got to confirm it through algebraic testing. Okay, and remember, you have to test each type of symmetry separately. Okay, all right, so this is our first time doing this. Okay, and every time you do an algebraic test for symmetry, here is my recommendation. Okay, remember, you're going to be making some replacements. You might be replacing x with negative x or y with negative y, or making both replacements. To make your life easier, I want you, before you do your tests, to rewrite the original equation so that the exponents are not apparent. Okay, so let me show you what I mean. I want you, and I'm going to put it in red, I want you to rewrite this equation. Okay, when you look at this, I see an x squared. Okay, that's a power, and I'm going to rewrite that. Okay, I'm going to rewrite this equation as y equals, instead of x squared, I want you to write it as x times x. That is what x squared is. Okay, and then minus 3 times x minus 4. Okay, all I'm doing is rewriting this guy so that the exponents are not apparent. Okay, instead of x squared, I want x times x. If I had had an x cubed, I want you to write it as x times x times x. Okay, the reason is you're going to be plugging in some negative values, and I don't want you to get confused with those negative signs, okay, in the exponent. So that's why we're just going to avoid exponents at all costs. Okay, all right, so let's start with testing for x-axis symmetry. Okay, so remember what you do to test for x-axis symmetry. Okay, the rule is if you start with xy, that is going to change to be, what are you going to do? Well, you're going to keep the x value the same, and you're going to change the sign of the y coordinate. Okay, so everywhere you see a y, you're going to replace it with negative y. Okay, so let's go ahead and we're going to plug in to this boxed equation. Going forward, we're working with what's in the box. Okay, instead of y, I'm going to replace it with negative y. Okay, there are no other y's involved, so I'm going to keep it the same. All right, so now I need to simplify. I've made the replacement. Now I need to simplify to see if I get the original equation back. Okay, all right, so I'm going to leave the left side alone. Let's simplify the right side. This is x squared minus 3x minus 4. Okay, in order to compare it to the original equation, which is in yellow here, the yellow equation is solved for y. Okay, we have negative y right here. Okay, so to compare apples to apples, we need both of them to be in the format y equals. Okay, so to get rid of this negative 1 in front of the y here, I'm going to multiply both sides by negative 1. Okay, whatever you do to one side, you have to do to the other. All right, so on the left side, negative 1 times negative y is going to be positive y. That's going to equal negative 1 times all this stuff in parentheses. You are going to have to distribute this negative sign through. Okay, so we're going to have negative 1 times x squared is negative x squared. Negative times negative is going to be positive 3x. And then negative times negative is going to be a plus 4. Okay, so now we are comparing this blue guy to the yellow guy. Are they the same equation? No. Okay, for example, in the yellow equation you have a positive x squared, but in the blue equation you have a negative x squared. They are not the same. Okay, so since you did not get the original equation back, there is no x-axis symmetry here. Okay, all right, so let's try the next type of symmetry. Okay, like I said, one type of symmetry does not imply either of the others. Okay, so you have to do them separately. For y-axis symmetry, we are going to start with a point xy. And so for y-axis symmetry, whatever type of symmetry you're dealing with, like it's y-axis here, that's what stays put. We're going to change the other variable. Okay, so we're going to replace x with negative x and keep y the same here. Okay, so go back to the original equation. Everywhere you see an x, you're going to replace it with negative x. Okay, so we're going to get y equals, okay, and remember, I am looking at this boxed equation. Okay, when you plug in, I want you using what's in the box to avoid the exponents. Okay, all right, everywhere you see x, you need to replace it with negative x. So instead of x times x, it's going to be negative x times negative x, and then you've got minus 3 times x. Instead of x, you have to replace that with negative x, and then minus 4. Okay, so everywhere I saw an x, I replaced it with negative x. Now I need to simplify, clean it up, see if we get the original equation back. Okay, so here we go. We're going to get y equals negative times negative is positive. X times x is x squared. Okay, so negative x times negative x turned into positive x squared. The next term, negative 3 times negative x. Negative times negative is going to be positive. And then you have 3 times x and then minus 4. Okay, so now we've got y equals something. We need to compare it to the original equation. So we can compare this green guy to the yellow guy. Okay, both have x squared, but they differ because the yellow has negative 3x and the green has positive 3x. So you did not get the original equation back. Okay, so that indicates the graph of this equation does not have y-axis symmetry. All right, lastly, we need to test for origin symmetry. Okay, that's the easiest one to remember. Okay, if we start with a point x, y, we need to replace both variables with their opposite signs. Okay, so we are going to go up. We're working with this guy in the box to avoid exponents. We need to replace x with negative x and y with negative y. Okay, so if we read from left to right, instead of y equals, we're going to have negative y equals, and then we're going to have equals. Instead of x times x, we have to make replacements of x with negative x. So we're going to have negative x times negative x. Okay, then minus 3. Instead of multiplying by x, we're going to multiply by negative x. And then we can't forget to tack on the negative 4. Okay, so we just went to our original equation. It's easier to work with the boxed version here. And we replaced x with negative x and y with negative y. Let's clean it up. We're going to get negative y is equal to negative times negative. That's going to be positive. X times x is x squared. And then negative times negative is positive, so plus 3x. And then minus 4. Okay, again, we will be comparing this to the original equation in yellow. So we need to compare apples to apples. So we need to have y equals instead of negative y equals. So we are going to multiply both sides by negative 1. Whatever you do to one side, you have to do to the other. All right, so on the left side here, negative 1 times negative y is going to be positive y. And then on the right side, you have to distribute this negative throughout the parentheses. Okay, so distributing the negative through the parentheses, that's basically going to change the sign of each piece. So we're going to end up with negative x squared minus 3x plus 4. Okay, so now we have y equals and y equals. Okay, I'm going to take this purple equation and compare it to the yellow equation. They are not the same. Okay, the yellow equation has a positive x squared and the purple equation has a negative x squared. Since we did not get the same equation back, we don't have the original equation, this means that the original equation's graph does not have origin symmetry. Okay, so this particular graph, a parabola, it has none of the 3 types of symmetry.